they turn that down. Hey guys, so I hope you guys learned a little bit from the definitions and just went over that yesterday, and you've worked on defining those definitions. I wanted to go over a few of the examples that they had in the book, starting on page 383, I believe, where we are actually going to graph a quadratic function. And so the difference between the linear and the quadratic functions, we've done linear so far this year. It's going to actually just make a straight line. We have learned that we can fill in numbers for our points, and we also have figured out we can use the slope intercept form where we can get the slope and the y-axis and determine our graphs from having the y-intercept and the slope. So we found a couple of ways that we can actually graph a linear function. So now we're going on to quadratic functions, and the first example that they give you is graphing the function x squared minus 2x minus 2. So this is our quadratic function, or our quadratic equation that we are going to graph. Okay? So the way that we can do this is basically find coordinates of selected points, and we can just make a table. Then we're going to plot the points, and then we're going to connect them. So for instance, for this one, let's just start out with our table here. This is going to have our equation there. This is going to equal y. We're just going to choose numbers. And when we fill these numbers back into this equation, we would get the following example. I won't work all of these out, but we would just put in simply -2. We're going to square that given the equation. Minus 2 times -2. Again, we're plugging that in for this x. And the equation has -2. And that's going to give us our y. When we work all of that out, that's going to give us a 6. We can do this where we plug in our x coordinate into this equation all the way down. So plug in -1, a 0, a 2, a 3, and a 4. When we plug all of that in, just like we did here, we would come up with these points. So we would come up with 6. We would come up with 1, -2, -3, -2, 1, and 6. So these are our x coordinates, and these are our y coordinates. Okay? So if we graph those, we're simply going to just graph these points. Okay? So our first point is going to be -2 and 6. So we would go over 2, or go back 2 because it's in the negative direction. So 1, 2, and up 6. 1, 2, 3, 4, 5, 6. It's going to be here. Our next point would be -1 and 1. So -1 over back 1, up 1. Then we're going to have, let me see, 0, 2. So we're going to start at the 0 and then just go down -2. It's going to be another point. And then our next point is 1 and -3. So over 1, down 3. 3. And then we're going to have our next point is 2 over 2, down -2. And then we're going to have 3 and 1 up. Let me see. 1. Let me see. What's the next one? Yep, 3 and 1. So 1, 2, 3, up 1. And then finally, we're going to have our last point of 4. 1, 2, 3, 4, and up 6. 1, 2, 3, 4, 5, 6. Okay? So now, when we graph this, we're going to put a line through our graph, and we have what is called a parabola. Okay, so think back to the linear equation, that's just a line. Quadratics are going to form a parabola. Okay, that was one of your terms yesterday. Right? Okay, so that is just graphing. All we did was just we just chose our input for x. We came up with an output or our range for our y coordinates. Okay? So it's pretty simple. So in this parabola here, we say that it opens upward. And we have a minimum point, and our lowest point is right here. Our lowest point is defined as 1, -3. That's our lowest point, our minimum point. That is the y, and then we call the y coordinate of this point the least value of the function. So our y coordinate of that point is our least value of the function. And then we have the vertical line, x equals 1, that contains the minimum point. That's called the axis of symmetry. So basically, if you were to fold this parabola in half, if you could visualize it, your axis of symmetry is right where it would go through to fold this parabola in half. That's called the axis of symmetry. Okay? So that's a quadratic equation. So one thing about the quadratic equation, you can also have a parabola depending on the values. You could have quadratic function, and it will tell you a little bit about, you can get some information from a quadratic function about the parabola that you're going to form. So if the domain of f of a set of real numbers, then the graph is a set of real numbers, then the graph of f is a parabola. Okay? If a is positive, the parabola opens upward, and if a is negative, the parabola opens downward. So from this quadratic function, we can write it in terms of this. The function is ax squared plus bx plus c. Okay? So this a right here is going to tell us if it is positive. So if a is positive, the parabola is going to open upward, just like the example we just did. If a is negative, then the parabola is going to open downward. Okay? So we did one where the parabola opened upward. And this is actually, just go back over that. That is called the quadratic function. Okay? So we did one where the parabola opened upward. Let's do another one where it opens downward, just so you can see. So we have another equation where we're going to say y equals k of x equals minus x squared plus 2x plus 2. Well, if we look at this equation and we think about our quadratic function, where we know that ax squared plus, plus bx plus c, we know that since there's this a in front of this, it's understood that there's a -1 in front of our variable there. So we know that a is negative. So already from this equation, we're going to expect that our parabola is going to open, when we graph it, it's going to open downward. Okay? We can already get that information from just looking at this equation. Okay? So let's graph it. We're going to do the exact same thing. We are going to choose values for our input. I feel like this pen, let me switch over real quick. I feel like it's not bright enough. So we're going to choose values. And we're going to have our input. Better. Is going to be x here. We're going to have minus x squared plus 2x plus 2 is our equation. It's also going to be just considered y. So we're going to choose -2, -1, 0, 1, 2, 3, and 4. We're going to then input our x into the equation to figure out our y. So here for the first one, I'll do the first one. It's minus, It's a minus and then a -2 because we're putting in a -2 for our x squared plus 2 from here times a -2 plus 2. That would, if we figured all of that out, would give us a -6. And then we would have a -1. If we put in a -1 into this equation, our -1 would give us, and we figured it all out, it would give us a -1 for y. It would give us a 2 for 0 if we input 0. For 1, it would give us a 3. For 2, it would give us a 2. And for 3, it would give us a -1. And for 4, it would give us a -6. So these are all our coordinates for x and for y. So then when we graph that, our first point is going to be -2, -6. We're going to start back going in the direction here. 1, 2, then -6. 1, 2, 3, 4, 5, 6. It's our first point. Our second point is going to be -1 and -1 and -1. So here and here. Then we're going to have 0 and 2. So not here, up 2 right there. It's going to be our next point. Then we're going to have 1 and 3. Go over 1, up 3. You can see our parabola is already starting to take shape. Then we're going to have 2. What was my other coordinate? Let me see. 2 and 2. 1, 2. 1, 2. Hey, shh. I'm filming. 1, 2. And then 1, 2. Shh. No. Shh. Go on. I got it. And then 3. 1, 2, 3. Down 1. Wait, that's going to go on there. And then we're going to have 4, 1, 2, 3, 4, and -6 here. So if you graph this, you will see that you're getting a downward parabola here. And then you'll be able to determine the maximum point. That is the greatest point. Hold on one second. Tate, I'm filming. That maximum point would be here. That's the highest point. That would be 1 and 3. Guys, sorry about my children in the background. And then the y coordinate of this point is considered the greatest value of the function, okay? So that would be the 3, okay? So also, the axis of symmetry would be through this point, and this would be considered our axis of symmetry. Again, if we were to fold the parabola, if you were to take the symmetry and fold this parabola back on the other half, that's called the axis of symmetry, okay? So I hope if this helps. One other point I want to make is that the minimum and the maximum point of the parabolas are called the vertex. So this would be also the vertex. If we have a parabola that's going upward, the point here, wherever it is, would also be considered the parabola. Sorry, the vertex. So I hope the vocabulary helped yesterday that we did. I hope this helps in thinking about how to graph the quadratic equation. Please be familiar with what a quadratic equation looks like. Again, we are just simply going to be putting in our input for x and determining the output, the y, or the range of y's and of y or y coordinates, and then we're going to simply graph those. And we have all of those terms for our parabola that we've made. And I've got a few examples for you. Tomorrow, I think we'll do a couple of examples like this for homework today. And then I'll have a Nearpod that I've found that's really interesting that talks about the trajectory of a basketball free throw shot. So I think it'll be something that you'll find kind of interesting. And I hope you guys feel like you're learning something.